Next, we have for transformations, we have rotations and reflections. Let's start off with rotations. There are three types of common rotations that you have when you're on a graph. You have 90-degree rotation, 180-degree rotation, and you have 270-degree rotation. The equation for each is like this. For 90 degrees, we have negative y x, negative x, negative y, and y, negative x. Try to remember when you have a graph and you start off, for example, here with your, and you want to rotate it 90 degrees, you start off with x, y. You flip it, y, x. Then you know that this is negative and this is positive. So it would be negative y, x. Then you keep flipping it here, so it would be x and y again. But you have negative, but you're on the negative side in the quadrant. So it would be negative and negative. And finally, you would switch it again, but this time you have positive, negative. So you make the y negative. That's how I remember each of them. Here's an example. Let's say you have a square that you want to move 90 degrees. And you have coordinate, you've moved the whole square, so you have negative 1, 2, negative 1, 4, negative 2, 4, and negative 2, 2. You know that the equation for 90 degrees is negative yx. So what you would do to rotate it is you would take one of the coordinates of the square, for example, negative 1, 2, and you would do this with each of them, but this is just one. You would take this and you would plug it into the equation, negative yx. So what this means is you would take the y and put it here, and pick the x and put it here. So it's like this. If it's negative 1, 2, and you plug it into a 90-degree rotation, it should be negative 2, negative 1. So you would do this with each coordinate of the square, and you should get the rotated square after you finish doing all of them. Next we have reflections. There are four types of common reflections. We have over x, over the x-axis. You have over the y-axis. You have over the y equals x line, and we have over y equals negative x over the x-axis. So if we had a square right here with coordinates 1, 2, negative 2, 2, 2, 2, 2, 4, and 1, 4, and you wanted to flip it over to the other side right here. Closer look at this. You know, if you're flipping it over the x-axis, you're flipping the value of the y, or the sign of the y, but the x is not changing. So if it's 1, 2, and you're flipping it over, the equation is simply x negative y over x. X negative y. So it would be 1, negative 2, and that would be the new coordinate of the reflected coordinate of that one coordinate of that square. Over the y-axis, it would be almost the same thing as the x-axis, except you're flipping the x, not the y. So if you have 1, 2, again, and you want to flip it over the y-axis, over this line right here, your x would change, and your y would stay. Over y, So over y, it would be negative x, y. So your coordinate 1, 2 would turn out to be negative 1, 2, changing the x and leaving the y the same. Over the y equals x line, you know that you're trying to get over this line. You would use y equals x over. So if you have a point, if the point negative 1, 2 that you want to flip over this line right here, you would simply plug it in, so it would be 2, negative 1. And your new coordinate would be right here. Over y equals negative x, it would be the same thing except with negative with each one. Thank you for watching.